Hello, this is a short video presentation on graphing linear inequalities in two variables. By a linear inequality in two variables, I mean things like we looked at on Thursday's assignment 209, 9x minus 2y greater than 8. It's an inequality and it has an x and a y. Before we start talking about how to graph them, and it's really a very easy process, I need to look into really carefully what is a solution. A solution to an equation in one variable is the number that makes that equation true. For instance, x plus 3 equals 6. We know that 3 is the solution because if we stick 3 in for x, we replace x with 3, plus 3 equals 6, 6 equals 6, we have a true statement. We know that 4 is not a solution because 4 plus 3 equals 6. 7 is not equal to 6, we know that 4 is not a solution. So if it makes it true, it's a solution. The solution to an inequality in one variable is all the numbers that make the inequality true. If I look at x plus 3 greater than or equal to 6, the solution is x is greater than or equal to 3. The reason that we graphed, and we spent a lot of time graphing these, the reason that we graphed them is because we're graphing the solution. You can't list all the numbers bigger than 3. You know, there's 3.001, there's 3.0057. There's pi, there's 17, there's a million, there's a billion, there's a trillion. You can't list them all. So we show all the numbers greater than 3 with an open circle. And since it could also be equal to 3, since 3 is part of the solution, we fill in the circle. This graph shows me all the numbers. How did that happen? Shows me all the numbers that are larger than 3 or equal to 3. All right, we're graphing the solution. A solution to an equation in two variables, now we're talking two variables, is the ordered pairs that make the equation true. All right, the solution to y equals 2/3 x plus 3 is an infinite number of ordered pairs. In fact, it's a line. If you look at this line, every one of the points on this line, every single one of them, is a solution. So we could pick any one. Let's pick this one right here. I don't want any decimals. -9, -3. Our equation, y equals 2/3 x plus 3. So I'm going to rewrite this. -9, -3, so -3 equals 2/3 times x plus 3. And x was -9. All we did is we took a point off of this line, and we get -3 equals, 3 goes into -9, -3 times, -6 plus 3, or -3 equals -3. Checks. So this point down here, -9, -3, is in fact a solution. But all these points are solutions. All right? The reason we graph the line, the whole reason for graphing the line is to see the solution. All right? We can't list all the answers. Any one of those ordered pairs would have worked. Which brings us to what we're doing today, linear inequalities in two variables. The solution to a linear inequality in two variables is an infinite number of ordered pairs, but it's not just a line. It turns out to be half the plane. And we're going to graph these. First of all, we graph our boundary. All right? If we look at it, inequality, y less than or equal to 2/3 x plus 3, the boundary is y equals 2/3 x plus 3. All right, the boundary is just a line. But graph it lightly, we might have to erase some of it. If the inequality is a less than or equal, or greater than or equal, if it has the little equal sign, then it's a solid line and you can darken it in. If the inequality is just a less than or a greater than, then we have a dashed line, and you're going to have to darken in, but make it look dashed. So I said make it really, really light, and then you can darken to do the dashing. Then we shade. That seems pretty simple. How do we shade? All right. Pick a random ordered pair, not on the line, and check it in the inequality, just like in assignment 209. I picked a random point. If it works, shade that side. If it doesn't, shade the other side. And the easiest thing to pick is 0, 0, unless it's on the line. So let's look at a quick example. All right, let's do an example now. And we'll make it simple, 2x minus 3y is greater than or equal to 6. All right, now we said, let's go back here, graph the boundary, just the line. So subtract 2x minus 2x, and I have negative 3y greater than or equal to negative 2x plus 6. I'm going to have to move this. We'll have to draw that later. And we divide by negative 3. So when we divide by negative 3, we divide everything by negative 3. And as always, we switch the direction. So we get y equals greater than or equal to 2/3 x minus 2. All right. So now we're going to graph this boundary. All right. So having troubles here. All right. Now we have our graph. So the boundary is 2/3 x minus 2. So I'm going to go 2/3 minus 2 up 2 over 3, up 2 over 3. I'm going to start here, and my line goes there. All right. Now, it's greater than or equal, so it's a dashed line. If it wasn't greater than or equal, then I would start erasing. I'd be making it a dashed. That's why I said do it lightly. But since it is greater than or equal, we just leave the line alone. And now we pick an ordered pair. I'm going to pick, because it's easy, 0, 0. All right? So y greater than or equal to 2/3 times 0 minus 2 Is 0 greater than or equal to -2? True that. 0, 0 is right here. I shade this side. Now it's easier with your pencil, but when you shade the whole side. And some of you will be really artsy with it, but we shade that side. It's very simple. We graph the boundary. It's either going to be solid or dashed. We pick a point. I use 0, 0, and then we shade. Simple enough. All right, I hope this makes sense. I know it is a little bit long, but hey, that's okay. Have a great rest of the weekend. Go Packers, and we'll see you guys tomorrow. Have a great day.